Okay, if you look, we are starting the digital systems. Okay, but before that, see, first of all, we need to know number systems. So before going to the first chapter, combinational one, so you must know some basics of the number system. So let me draw a table. It will help you to know what is number system. Okay, so let's see. This is decimal with base as 10, then binary with base 2, then octal base 8, then hexadecimal base 16. So these are the basics of the number system, where we should know how to represent the digits in different base. If we move to decimal, so we can represent as 00, 01, 02, 03, 04, 05, 6, 07, 08, then 0, 9, 10, 11, 12, as we have studied everything in the mathematics, 13, 14, 15. Okay, so if you move to binary, how will you represent these things? You will write as 000, another one 0001, 00010, and 3 as 0, 0011, and 4 as 0100, 100, and 5 will be 0101, and 6 will be 0, 6 will be 0 1 1 0, 7 will be 0 1 1 1, 8 will be 1 0 0 0, 9 will be 1 0 0 1, 10 will be 1 0 0, sorry, not 0 0, it will be 1 0, again it with 1 0 1 1, and 1, it will be 1 1 1, just a minute, yeah. So 11 is 1011, 12 will be 11100, this will be 1101, 14 will be 1110, and 15, as you know, 111. So this is the binary representation. We go like 1 0 1 10 11, so we can basically represent in just 0 and 1. But in octal, how can we represent? We can represent 00 as 00, then 01, then 02. Let me make table so that we don't go out of order. So let's make lines so that we don't go out of order. Okay, if you look here, 00 can be written as 00, then 01 will be written as 01, then 02, 03, 04, 05, 06, 07, till the number 7, till the decimal number 7, we will write it as 0 as 7. But from 8 we will write as 10, 11, 12, 13, 14, then 15, 16, 17. So like this is the representation of the octal number system. Why till 07 we wrote 0, why till decimal number 7 we wrote 07? The point is like till 0 to 7 it is 8 digits, right? 0 1 2 3 up to, so it is like 8 numbers. So after that, at 8 we have something different. We have 10, 11, 12, 13, 14, 15, 16, so it continues till like this. We continued 7. If we look at the hexadecimal, so 0 can be written as 0 1 2 3 4 5 6 7 8 9, 10. 10 cannot be written as 10. In octal we were writing 10, but in decimal, hexadecimal, we will write A, B, C, D, E and F. So this is your table for the different conversion. So this is a number system table with different bases like base 10, base 2, base 8 and base 16. Let's give an example so that you can understand. Let's do hexadecimal to decimal conversion. Okay, from hexadecimal to decimal conversion. Example B6 5F base 16. So this is a hexadecimal number. How will you convert to decimal? So you know B can be written as, if you look B here, B can be written as 11. So write B as 11 into, so this place is the 0th place, 1's place, 10's place, 100 place. So you can write this 16 to the power 0, this is 1's place, 16 to the power 1, then 16 square, this will be 16 cube. So these are different places. So how will you write? So since it will be 11 into 16 to the power 3 plus 6 into 16 to the power 2 plus 5 into 16 to the power 1 plus F can be written as 15. You see the table F. So 15 into 16 to the power 0. So if you put this value in the calculator, it will be 4, 6, 6, 8, 7 base. As you know, it is converting to decimal, so base 10. Okay, let's look to another one example. Let's say you have something like this. FB62 base 16. So you have to convert to decimal. So how will you do this one? This one 16 to the power 0. Let's add a number here also. AFB62, one more. So this one will be 16 to the power 1. Okay, let me write down better. 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3. This is 16 to the power 4. So you will write A can be written as, see, if you look to this place, A can be written as 10, because see, we are converting from hexadecimal to decimal. So you have to look which table we are converting, you have to look that table. So A can be written as 10. So you will write A as 10 into 16 to the power 4 plus F can be written as how much? 15, right? If you look at the table, F is 15. So into 16 to the power 3 plus B can be written as 11 into 16 to the power 2 plus 6 into 16 to the power 1 plus 2 into 16 to the power 0. You will put the value in the calculator and find that value. So whatever value will come, base 10. That's the hexadecimal to decimal representation. Now from binary to octal conversion. So binary to octal, see, if you have the number 1 0 0 1 0 1 1 0 0 0 1, then 1 0 1, then 0 1 1, then you have 1 1 1, 1 0 0, then 0 0 0, then 1 1 0, base 2, right? Convert this to octal. So as I said, octal, so how will you convert this? Step 1, there is a formula. You will put log 8 base 2, because since it is octal, our base the base is 8, so you will put log 8 base 2 is 3. So basically you will make 3 pairs, right? You will make 0 1 0, this one 3 3 3 3 3 3, then 3, then 3. You'll make 3 pairs and then write this as this one. You know how to write this one. If you look to the table here, from binary to octal, let's say 0 1 0. So this is the octal number system, this is the binary number system, right? So if you see at 0 1 0, 0 1 0, if you see this is 2. If you see 0 1 1, it is 3. 1 0 0, it is 4. Okay, so this is 2, this one will be 6. You look to the table, then you will, this one 1, you know, this one will be 5, this one is 3. 1 1 1 is how much? 7. And this one is 4. Obviously 0 0 everything is, so this is 0, this is 6. So how will you write this? So you will write this as, this one is 2 6 1 5 3, and there is a point, then 7 4 0 6. As we are converting from binary to octal, so we'll write base 8. Understood? So this is the way how we will write. If we see to let's say binary to hexadecimal, decimal representation. If you see binary to hexadecimal, let's say you have a number 0 0 1 0 1 1 0 0 0 1 1 0 1 0 0 1 1, and point 1 1 1 1, then 0 0 0 0, then 0 1 1 0. So this is the binary number given. You have to convert to hexadecimal. So step 1, what you will do, you will find the base. So base is 16, right? Hexadecimal means 16. So you will do log 16 base 2, which is 8, sorry 4. So that means 4 pairs. Okay, so 0 1, so 2 3 4, 0 1 2 3 4, 0 1 2 3 4, 0 1 2 3 4. So make 4 pairs. Okay, then you will write, this one can be written as, if you go to the table and see, we are doing from binary to hexadecimal. So if you go to the table and see binary table and hexadecimal, 0 0 0 1 0 can be written as 2, 0 1 1 can be written as 3, this can be written as 4, this can be written as 5. So we will keep on seeing the table. Once you get practice with the table, you can do it faster. So this can be written as 2, this can be written as C, this can be, if you see 1 double 1 1 0, you see 1 0 0 1 1 0 0, this is C. 1 1 0 1 is D, so it continues. So this one will be if you see, this one is 6, this one is B, this one will be F, this one is 0, this one is 6. So if you write 2C6BF06, since we are converting from binary to hexadecimal, we will give the base 16. Next we will see the conversion of number from octal to binary, the reverse thing we will check. So from octal to binary, okay, there is a number given, let's say 673.12 base 8, because it is octal. So how will you write? you know how to write 6, so you will go to the table, you see. So how to write the 6 in octal, in binary, octal number. Okay, we are doing from octal to binary. So how to write this? So since we are doing from octal to binary, we will do log 8 base 2, log 8 base 2, that means is equal to 3. That means we require 3 digits, so no need of writing another one digit. So if you see here, it is 110. Okay, so we will write. So you will ask me, should I write 0110 or just 110? Both are the same for 6. Which one you should write, and how many digits you should use? In this case, you should use 3 digits. Why? See, how will you know? Because since it is a octal number, so you will do log 8 base 2, which is 3. Okay, so you will use 3 digits. So 3 digits per representation. So 6 can be written as 110. 7 can be written as you know, 111. 3 can be written as 011. 1 you know how to write 001. 2 you know how to write 010. So you will write at a time together 110, 111, 011, 001, then 010, like this. Okay, base 2. Understood? So if we see another one from hexadecimal, from hexadecimal to binary. Okay, you see here, it's bad handwriting, bi, yeah. Okay, binary. Let's see example 3a6.6 point c. Okay, this is the hexadecimal representation. And how will you write? Okay, you can write 3 as, okay, how many digits you should use? Should you write 01011 or 0011? So as I said, the formula log 2 base 16 is log 16 base 2, which is 4. So you will use 4 digits. So 4 digits will be used. Okay, so 4 digits will be used. So it can be written as 011, no, 001, 0011. This one as 1010. 6 can be written as 0110, and this one can be written as 1100. You can see from the table and try to write. How can we write 3? How can we write a? Because if you see here, a can be written as, we are doing from hexadecimal to binary, so a can be written as 1010. So you will write that one. Okay, so a can be written as 10. So I wrote it. Finally you will write 0011, 1010, then 0110, then 1100, then base 2, as I said. So this is the way how you will convert from hexadecimal to binary, octal to binary. And before that also we saw how we will convert binary to hexadecimal, and then from binary to octal. So this was the conversion. Okay, but if I ask you, okay, let me give you something else. Okay, so let me teach you some important operation, then we will come back to this. Arithmetic operations. Arithmetic operations. In arithmetic operations, so basically if you are adding this one 0100 plus 10001, so how will you add? It's a binary operation, binary adding. So how we add 0? So 0 plus 1, that means 0 or 1 is 1. So this will be 1. 0 or 0 or 0 will be 0. So this is 0, this will be 1, this will be 1, this will be 1. This is the answer. Okay, so this is called as AUGEND. Okay, argument. And this one is called as addendum. This one is the sum. Okay, let's say you have one more as 1 0 1 1 0 and 1 0 1 1 1. So you have to add it. So 0 plus 0 or 1 is 1. So 0 1 plus 1, 1 plus 1, what will be? It will be 1 0, because you see, first 0 comes, then 0 0, then 0 1, then 1 0, then 1 1. So when you add 1 plus 1, so after 1, if you go add one more step, it is not like decimal adding, so that we will write 2. This is the binary addition. So if we add one more, we go to this. From 1, first 0 1, then 1 0, then 1 1. So if we add a 1, we get a 1 0. So you will 1, so 0 will be here, we cannot write 1 0, so 1 will be carried. This is the carried one. So similarly 1 plus 1 is 1 0. So 1 0 plus 1, so will be 1 1, right? 1 will be here and 1 will be carried here, because you see 1 plus 1 will be 1 0, 1 plus 1 will be 1 0, but since there is a 1 carried up, so you will add that one. So 1 0 plus 1 will be 1 1, next one is 1 1. So 1 will be here and 1 will be carried. So 0 plus 0 is 0, since 1 is carried, so it will be 1, and 1 plus 1 is 1 0. So this is 1 0 1 1 0 1. This is the way of how we will add the things in binary addition. If you look to, these are very basic things. So if you look to subtraction, let's say 1 0 1 1 0 is there, and you have to subtract 1 0 0 1 0. So 0 minus 0 is 0, 1 minus 1 is 0, because 1 minus 0 is 1, then this is 0, and 1 minus 1 is 0. This is the binary representation. Suppose we have this one, we have like 1 0 1 1 0, and this is subtracted as 1 0 0 1 1. So how will you do this? So here 0 minus 1 you cannot do, so you will carry 1 1 from here. So since 1 will be carried from the tens place to the ones place, so 1 minus 1 will be 0, but this place is empty, this place is 0 now, so 0 minus 1 cannot happen, so it will carry one more 1. So 1 minus 1 will be 0. This place is empty, this place is 0, right? So this place will be 0 minus 0 is 0. This one will be 0 and 0 will be 0. Okay, see here, no, this one was not. Let me give one time more. Yeah, it was 1 0 1 1 0. So, and what was subtracted? We were subtracting 1 0 0 1 1, right? So since 0 minus 1 cannot happen, so this one will carry a 1. So it has a 0 bit and it carried a 1 bit, so it will be 1 0. So this one will be 1 0. So 1 0 minus 1 will be 1, because if you see the binary representation, it is 0 1, then 1 0, then 1 1. So like this. So if you subtract 1 from 1 0, it will be 1. So this one will be, since 1 is carried away, this one will be 0, so it will carry 1 again, this will become 1 0, so 1 0 minus 1 will be again 1, this one will be 0 because already 1 is carried out, so this one will be 0, so 0 minus 0 will be 0, so this one will be 0 and 0 minus 0 will be 0, so answer is 0 1 1. This is the difference. Okay, so these were very basic things of the binary number systems, and so it's your duty, since it is a crash course, you must go into it into detail if you don't know these basics. So let's see one more example. Okay, how will you convert from conversion of decimal to octal? Okay, octal. If you have a number, let's say example 153. Okay, 153 is decimal, so convert this decimal 153 decimal number to octal. Okay, so how will you do? One, so octal is base 8, so 153 you divide by 8, so how much will be the answer? So if you put 9 8 1, so 1, and this will be 8 ones are 8, this will be 993, so this will be 19, and remainder will be, if you divide this with 8, so 8 ones are 8, this much will be, so 63, so this one will be 9, 8 9s are 72, this is 73, so 8 9s are 72 and remainder is 1, so you do there, so remainder is 1, so every time you will write the remainder, you will divide this and then write the remainder, again you will divide 19 with 8, then so you know this one, so 8 2s are 16, so 16 you will 2s are 16, so how much remainder? If you divide this 8 2s are 16, it will be 3, so you will write here as 3 as remainder, then again you will divide this by 8, so if you divide 8 with 2, it will be 0, so remainder is 2, 8 zeros are 0, so remainder is 2, so you will write all the reminders in the right hand side. Okay, so if you look, we have to go from the back end to the top, so it will be from here, all the reminders, there are 2, 2 is the remainder, then 3, then 1, so the octal representation, so from decimal 153, the octal conversion is this, you will write base 8. If you look to one more, from decimal to binary, if you look 41, let's take convert 41 to binary. Okay, this is decimal, so again same process, but here binary is base 2, so we will divide by 2, 2 will be 2 to the 4, 0 20, this will be 20, this is the quotient part we are writing, so remainder will be 1, 2 into 10 is 20, remainder 0, 2 into 5 is 10, remainder 0, so this one 2 into 2 is 4, remainder will be 1, then 2 into 2 is 1, so remainder is 0, so you will consider all these. Okay, so you will write from down to the up, it is, so decimal representation of 41 base 10 is equal to, you will write 1 0 1 0 1 0 0 1, this is the binary representation of 41. Okay, let's move to the concept. What is BCD? What is binary? So BCD. BCD stands for binary coded decimal. Okay, binary coded decimal. So this here you have the decimal system, and here you have the BCD digits. Let's check what are these. 0 1 2 3 4 5 6 7 8 9. 0 to 9 we are writing the decimal number. So what will be the BCD digit? 0 0 can be written as 0 0 0. Then this one will be 0 0 1. This one will be 0 0 1 0. This one will be, let's draw the lines. Yeah, third one will be 0 0 1 1. Fourth one will be 0 1 0 0. Fifth one will be 0 1 0 1. Then sixth one will be 0 1 0 1 1 0. Seventh one will be 1 0. Yes, seventh one will be 0 1 1 1. Eighth one will be 1 0 0 0. Ninth one is 1 0 0 1. So this is the BCD display of from decimal to binary. Okay, this is the BCD representation. So if you have a conversion like convert 185 from decimal to BCD. Okay, how will you convert? How will you write 1 in BCD? 0 0 0 1. This one 8 you can be written as 1 0 0 0. This one can be written as 0 1 0 1. So you will write this as 0 0 0 1, then 1 0 0, then 0 1 0. You will write it as BCD. Okay, and whenever you have so basically BCD is represented in 4 digits. So how to write it in binary? Simple, very simple. You have to join everything. Binary will be 1 0 1 1 1 0 0 1 base 2. This will be the binary. How you will do the binary? As I said, you will write 185 1. You will write this as 0. This can be written as 1. This can be written as 1 0 0. So you will give write this binary representation from the table and convert it. So basically these are the way how you will convert from decimal to BCD, and this is the BCD representation from decimal to BCD. So these are the basic things you must know about all this. So one more thing to tell is the gray code. So gray code can be written as this. Gray code can be written as C. Here you have the binary code. That's right. Binary code. Okay. So if you see here binary code, you can write 0 0 0 0 0 1 0 1 0 0 1 1, then 1 0 0, then 1 0 1, then 1 1 0, 1 1 1, then yeah. But if we write the gray code here, gray code, you will write 0 0 0 0 0 1, then 0 1 0, then no, not 0 1 0 0 1 1, because See, in gray code we maintain the Hamming distance. If you see the number of digits changing in binary, if you see here, 0 is remain as 0, 0 remains as 0, 0 becomes 1 here. So 1 digit change. If you look here, this one is changing, this one is changing. So 2 digit is changing. Here this is changing 0 to 1, this 1, 1, this remains same. So 1 digit is changing. Here 2, 3 digits are changing, so 3 digits are changing. So if we move to the gray code, every time whenever we move to the next code, only 1 digit will change at a time. 1 digit will change. If you look here, 0, if I would have written 0 1 0, then my digits would have changed, see, from 1 to 0 and 0 to 1. So 2 digits are changing, which is not possible in gray code. So we have to remove this part and write 1 0 1 1. If I write this one, the next digit is 0 1 1 after 0 1 0. So if I write 0 1 1, 1 remains as 1, 0 remains as 0, but only one digit changes, that is 0 and 1, this one. So there is a 1 digit change. Next one you will write 0 1 0. Next one will be, wait, if you look the next one will be 1 1 0, then 1 1 1, then 1 0 1, then 1 0 0. Okay, if we look at every point here, the 1 is remains as 1 and only 1 changes to 0, the last digit. So there is a change of only 1 digit. If you look to the next one, also same, change of only 1 digit, only this one is changing, right? So 1 digit changing. If you look here also, 1 digit is changing, 1 digit. So every time only there should be a change in digit, only 1, not more than 1. So that means the Hamming distance must be 1. Okay, Hamming distance means the change in digit. Must be 1. So at every time whenever we are going from one code to other, I mean one digit to other digit, so we have to change only one digit, not more than that. This is called gray code. Okay, let's study something about one hot code. Basically I'm telling you in a faster way because we will not use like so much. We just need to know what is gray code, what is BCD code, what is binary code, what is decimal, everything you just need to know. So this is the very basic class. So in one hot code, every time in every section you will have only one. So in one hot code you will have, like, let's say decimal I'm writing from 0 1 2 3 4 5 till 5 I'm writing. So this can be in, if you write this one hot code, it will be 0 0 0 0 and 1. So how many digits? 1 0 1 2 3 4 5, 5 digits. So 5 digits will be used, 0 0 0 and 1. This one will be 0 0 0 1 0. There will be no changes of like there should not be like this 0 0 0 0. There should be one digit present in every code. See, there should be only one, not more than one. 1 must be present, 1 must be present, but only one time I am saying. So 1 will be only one time, not more than one time. So this will be 2 can be written as 0 0 1 0 0. This one 0 0, sorry, and the next will be this one, right? So this one will be 1 0 0 0 0. So see, we need one more digit to represent this. I cannot write more than here, so I need one more digit, so I have to add a 0 here. Okay, so 5 I can write now, this one. So I need one more digit to represent this one hot code. So this is one hot code. Let's say you have to represent A, B, C, D as one hot code. So since there are 1, 2, 3, 4, 4 numbers, so you will have 4 digits. So you will represent it as 0, 0, 0, 1. This one will be 0, 0, 1, 0. This one will be 0 1 0 0. This one will be 1 0 0 0. It's like at every time you will have only one 1, and every time, and since it is at ones position, then tens position, then hundred position, then thousand position, so the position of ones will change, but there will be only one, no more than one. So this was the end of the number systems. Then we will study about k logic gates. So we'll study logic gates and k maps, which are really important for all of our digital questions.